All right, so next up we're going to be looking at solving for the vertex. Now, something that I can't emphasize enough is a vertex is a point. It's an xy ordered pair. So when we are looking through and solving for this, we need to get both an x and a y value. Now, something we do know already, and we can actually use this from our axis of symmetry, is the x-coordinate of the vertex and the axis of symmetry are actually both exactly the same. So we're going to get, again, the same answer for that. And a lot of people have a tendency just to solve for x and think that they're done. But again, remember, after solving for x, we still need to go back and find what y is. So let's repeat an example we did from above. And one more time, let's go through and calculate this x value. The difference now at the vertex, though, is we add a step. We have to also plug in and solve for y. So we have an axis of symmetry at x equals negative 1.5. That's also the x value of our vertex. So let's just mark that on the side here. Again, those two things are different. So we can go back and we can take that x value and plug it in. So as a reminder, this is x squared plus 3x plus 2. We know what x is. We just solved for it with our vertex. So we're just going to take that x value and plug it in everywhere that we see an x. Once we do that, we're going to be able to solve for our y value. So negative 1.5 times negative 1.5 gets us 2.25. 3 times negative 1.5 gets us minus 4.5, and then we add 2. And it looks like our final answer here we get is negative 0.25. All right, so again, check your steps. Always a good opportunity right now to go and take a look back. To be honest, I do this right now because I want to make sure I'm not making a mistake in a video. And with that, we've actually just solved for our vertex. So we have negative 1.5, comma, negative 0.25. So again, we took the x value that we already calculated, we plug it back into the original equation, and then we can go through and have our xy ordered pair for our vertex. Now, what does this look like on a graph? We go negative 1.5 to the left and down just a little bit. That's also our axis of symmetry, but we've now also identified what our vertex is. So we can go through and draw on a rough estimate of what this graph might look like. So having the axis of symmetry and vertex are two very important points. Again, remember, we already know how to solve for our x-intercepts. And if you're like, Mr. R, you said we know how to do this. Now show me, how do we actually do this? Well, when we go through with, remember, this is our original function. We factor it. And then we know that we're going to use 2 and 1. So we're going to have x plus 2 and x plus 1 equals 0. We can set each of these equal to 0. And then we can solve. Okay, so we have negative 2, and we have negative 1 as our x-intercepts. And if we look at our graph, this actually makes perfect sense, because this value right here very well can be x equals negative 2, and that right there can very well be x equals negative 1. So that's kind of putting together all of the pieces from what we've just done and basically using them to draw, I would say, a very well-educated guess for a graph. So the last questions here are going to ask you to calculate some vertex points, and then the final set's going to ask you to do all of the pieces. So do the axis of symmetry, do the vertex, and calculate those x-intercepts, just like we did down here, and then put them all together on a graph. So as always, any questions, feel free to reach out. Appreciate you taking the time.